All right. Hopefully you guys enjoyed the video. However, enjoy it or not, we will discuss it on Friday when I get back. I just want to kind of finish up the last question in the notes to help you complete the worksheet that Miss Lawrence is going to give you in class. It has 2 questions where you calculate the power. Also, make sure you tell Miss Lawrence that I don't show movies in class all day, every day. If you look at page 21, in the notes, this top one we'll do tomorrow when I get back. But this one down here is where you're an example where we need to calculate the power. So I'm going to work through this one right here, right now. So get your notes out, follow along. I'm going to kind of go fast, but whatever. Suppose you believe the average heights of students that play high school soccer is taller than the average heights of all high school students. The mean heights of all high school students is 67.8 inches. Suppose the true average height of the soccer players is 69 inches, and the standard deviation is 2.7. Suppose we take a sample of 30 soccer players and measure their height. Find the power of a z-test at an alpha level of 0.5. Assume the population standard deviation for the high school and the soccer players is 27 inches. So basically, we're going to use a z-test. This is one of the rare cases where we use a z-test, partially because a t-test is kind of complicated and it's hard to do because you don't know what the sample standard deviation is going to be. So let's assume that we know the true population standard deviation is 2.7 inches. That's going to be the assumption of this power calculation. Let's set up the null and alternate. The null is that soccer player heights are the same as high school heights, against the alternate, which we want to kind of prove that the heights are actually larger than the 67.8. So the true mean is actually 69. Therefore, we can calculate the effect size. You need to know what effect size is for Monday's test. It's the difference between the true mean and the hypothesized mean. So it looks like it would be about 1.2, I think, whatever. That's the effect size. All right, so in order to do this calculation, we first need to look at the hypothesized distribution. If the null hypothesis is true, then the true mean is 67.8. Of course, it's not. This is the true mean, but under the hypothesis, the assumption is that it's this. Then we're going to take a look at the standard deviation of the sampling distribution of sample means, which is 2.7 sigma divided by the square root of 30. So we will reject the null hypothesis if we get a value, since it's a one-tailed test on the upper end, if my x bar crit is such that the area to the right of it is in the top, if it's in the top 5%. So if my mean is larger than this x crit, I would reject. So let's find that x bar crit. That's going to be the inverse normal in your calculator. Area to the left is 0.95, mean is 67.8, and the standard deviation is your 2.7 over the square root of 30. So if you type that in your calculator, it'll give us that critical cutoff value for my mean. Inverse norm um, 0.95, area to the left, 67.8, and then 2.7 over the square root of 30. So 68.6 about. So that means if my mean is bigger than this 68.8, then I'm going to reject the null. But here's the thing. This is the hypothesized value. It's not the true value. So now let's take a look at the true distribution. The true distribution is not centered at 67.8 because this is the true value. It's actually centered at 69. Standard deviation of the sampling distribution of sample means is the same because this is a population standard deviation. So now what I want to know is, since I'm actually taking my sample mean from this distribution, what's the likelihood that I get a sample mean that is bigger than that 68.8 or 68.6 that I found before? And this right here is the probability that we're going to reject the null. That's the power of my test, our test. That is, calculation for that is norm CDF, lower bound 68.6, upper bound infinity, mean, standard deviation. That's it. Norm CDF. Let's select this value to positive infinity, comma 69, comma. Be nice if I could grab this and copy it. Control C. Is that going to work? Control V. 68 or 78.5. So that's the area. This is 0.785. So basically the power of my test is 78.5%. So if this assumption is true, if the heights of soccer players are really 69 and not this, not the 67.8, then there's a 80% chance about that I'm going to correctly reject the null hypothesis and conclude that soccer players are actually taller. I mean, there's a 20% chance, so one time out of 5, I'm going to incorrectly fail to reject. So that's how you calculate power. It's actually not that difficult of a calculation, but you do need to practice it. So good luck, and I'll see you tomorrow.